Good morning, friends. Today we will discuss on one technique on which we can find the crystal structure, and it is X-ray diffraction. So first of all, we will see that what are the applications of this X-ray diffraction. So there are lots of application of it that first one is measure the average spacing between layers and row of atoms. As we know, the crystal structure have arrangement of atoms, and the spacing, if we know the spacing between them, so we can arrange them and use them for the analysis and determine the orientation of single row crystal or grain, the orientation of that crystal. If the material is unknown, though we can find the crystal structure, measure the size and internal stress of small crystalline region. So these are the application of X-ray diffraction. Now we all know that crystal lattice are the arrangement of atoms in a regular manner. So this is a simple cube in which we have atoms. So these atoms represent the nucleus of any atoms, and the space between them are always constant. So our intention for the X-ray diffraction is to find this distance. If we know this distance, we can arrange our atoms in crystal lattice structure. Now how can we find that? So there is a one X-ray source from which X-ray is emitted, and other is X-ray detector. Like we are going for X-ray of our chest. So X-ray technician emit the X-ray source from his machine, and there is a film, X-ray film behind our body. So we can the film is generated on the X-ray detector. So likewise we have lots of atom structure in the material placed at the sample table, and X-ray is emitted from X-ray source, and it is impacted on the atoms, and from that it is diffracted from this atom and received in X-ray detector. So as you know that if X-ray is emitted from this and it is diffracted from particular position of atoms, so this from that we received it on the X-ray detector. So we can say that this is the position of X-ray atoms, and even we are changing for the same wavelength, we cannot achieved for the all atoms. So we are continuously changing the angle of the X-ray, and we find the position of all atoms or the distance between all atoms. And all we know that the always this angle is theta if we diffraction is placed, and this angle also will be theta. So from that we are going to derive Brake's law equation. So for that we are considering this. We have layers of atoms. This is the first layer, this is the second layer, and this is the third layer. Now this distance, we all know that this is the ray in which this distance is lambda by 2, wavelength is half, so this will be the lambda by 2. Same way for next layer, this length become lambda and this length become lambda also, and for next layer it will become 2 lambda for this and 2 lambda for this. So from this we can generate one triangle to find the distance. So this is the distance d and this is the angle theta. So from that we generated one triangle in which this is the angle theta, this is the distance d, and this is the length lambda by 2. So using trigonometry, sin theta is equal to lambda by 2 upon d. So rearranging this equation, we find that lambda is equal to 2d sin theta. In general sense, as we arranged, as we discussed, at a different layers, the size of opposite side is changing. So general equation is 2n lambda is equal to 2d sin theta, and this is Brake's law. Thank you.